Unit 2, Lesson 6, Side Angle Side Triangle Congruence. So our learning goal is let's use definitions and theorems to figure out what must be true about shapes without having to measure all parts of the shapes. All right, so let's see what they mean. In the first warm-up, 6.1, Information Overload, they say to highlight each piece of given information that is used in the proof and each line in the proof where that piece of information is used. Okay, so let's see here. They tell us that AB is congruent to DE, right? All right. And they tell us right here in step 1. AB and DE are the same length, so they are congruent. Therefore, there is a rigid motion that takes AB onto DE, right? Maybe a rotation, maybe a translation, all right? Something goes on right there, so that works. Okay, let's look at number 2. Apply rigid motion to triangle ABC. The image A will coincide with D, and the image of B will coincide with E. Well, they didn't give us anything that said that A goes on to D or B goes on to E, right? They didn't give us that in here, so I'm not going to highlight that. Step 3, we cannot be sure that the image of C coincides with F. Again, we don't know if C maps onto F, so I'm not going to highlight anything with number 3 because it says if necessary, we reflect ABC across DE. Well, we don't. Yeah, we don't know. This reflection will not change the image of A or B. We don't know anything about C mapping onto F. We know that angle C is congruent to angle F, but they're not talking about the angles. They're talking about the points. So number 3 doesn't really fit our narrative. Let's see. Number 4, we know the image of angle A is congruent to angle D. Ooh, they said that. They said that up here in the given, right? Angle A is congruent to angle D. So again, number 1 was this part. Number 4 was that part. Okay, and angle A, angle D. So we definitely know that. All right, so we have this side here, all right, being congruent to that side here. This angle here being congruent to this angle here. Okay, let's kind of read on, see what else they're giving us. Number 5, they say C prime must be on ray DF since both C prime and F are on the same side. Well, they didn't tell us anything about, and then they say same side as DE. Did they say anything about C prime and F in the given? Did they say anything about C and F prime or C prime and F? No. They just said angles, right? The angle C, angle F. So number 5 doesn't make sense. Number 6, segment D C prime is the image of AC. Do you guys see a D? Was it D? What is it? Was it DC prime? Oh, wait. I'm reading the wrong one. That one. Do we see a DC prime anywhere in here? No. That does not make sense. So what about 7? What does 7 say? We also know that AC is the same length as DF. So DC prime and DF must be the same length. Did they say anything about congruency of AC and DF? Ooh, they did. Right? Because think about it. If they tell us they're congruent, right? Since they're congruent, the lengths have to be the same. So they did give us enough to go off that. All right, so let's take a look. They said AC is the same length as DF. oh, that's a side. So this side is congruent to that side. And as you notice, these three parts are enough to prove that these two figures are congruent to one another. Okay? So line, so my answers, right, they gave us that AB is congruent to DE, right? They gave us angle A being congruent to angle D, and they gave us that AC is congruent to DF, which satisfies step 1, 4, and 7. Okay, and when it comes to proofs, you can only work with what they give you. This is the only pieces they gave you. All right, every other step in this proof are dealing with things they did not give us. Okay, so they only gave us enough information for 1, 4, and 7. And I know that because just at glancing at 8, they're still talking about C prime and F, right? We don't know anything about the points. All right. Same thing with mapping from point to point, right? They didn't give us any mapping information. All right. They only gave us what I highlighted. All right. All right. So moving on to activity 6.2. And they're talking about two triangles have two pair of corresponding sides. And it looks like it's a sketch. Let me take a look here. So proving the side angle side triangle. So we're proving, again, side angle side triangle congruence theorem. Okay, if you ever see me write that, that's exactly what I mean. Okay. So two triangles have two pairs of corresponding sides, and corresponding angles between those sides are congruent. Sketch two triangles that fit the description and label them LMN and PQR. So that segment LM is congruent to PQ, and then LN is congruent to PR. Angle L is congruent to angle P. Okay, so let's see here. Two pairs of corresponding sides. Okay, so I'll call that LM. Okay, and so we need two pairs of corresponding sides to be congruent, and the corresponding angles between those two sides are congruent. Okay, I understand what they mean here. So they're saying LM is congruent to PQ, and then LMN. So here's, all right, here's in. Okay, sorry, there's in. All right, I got my sides, and I'm going to do the good old-fashioned copy and paste. Okay, except what I'm going to do is this is going to be called PQR. That's what they wanted us to do. And then, yeah, we are working off of two triangles here, so might as well finish off the triangle. All right, here's LN and PR. If you guys notice real quick that when I drew LN and PR, they're both the same length, right? So they're forced to be congruent to one another because we have LM being congruent to PQ, right? We have those two sides. We have angle L is congruent to angle P. and then they say Ln is congruent to PR. Oh, okay, so it's this side that they wanted. So not that, and this is the angle. All right. Sketch two triangles that fit the description. Okay, so there you go. Those are my two triangles. All right, notice how with side angle side in this condition, it forces MN and QR to be congruent to one another. Okay, so that's why that congruence theorem exists. If you have those sides, right, if you have the side angle side pattern between two of these triangles, every other part of those triangles would have to be congruent. Okay, so let's see. Use a sequence, so this is number 2, use a sequence of rigid motions that takes triangle LMN onto PQR. For each step, explain how you know that one or more of these vertices will line up. Well, in this situation, right, I could do a translation. It says a sequence, but because the way I drew these two triangles, like even their orientation is the same, so I can get away with just saying translation along LP, right? And then LM would map onto PQ. If I do that real quick, if you watch, if I do that from L to P, notice how those triangles will map perfectly onto one another. Okay, so even MNQR, right? So if you think about it, if these two triangles, if triangle LMN is congruent to triangle PQR, comma, all corresponding parts of congruent triangles all corresponding parts of congruent triangles are congruent. Okay. So if they're the same triangles, expect every part to be the same. So if you were to do a translation along LP to where LM maps onto PQ, we know that all the other parts are going to line up. All right. If you ever hear somebody say Cpctc, what they mean is corresponding parts of congruent triangles are congruent. Okay, so if you ever see Cpctc, corresponding parts, congruent triangles, congruent. Okay, basically, if the whole triangles are congruent to one another, all their little parts are, and all their little parts should be congruent to their corresponding parts. Okay, let's move on. Activity 6.3. We have these two kids. They're arguing over an isosceles triangle, and that's a definition, right? That's a definition. So I think that's the part in the the learning goal, right? Is using definitions for proofs. So we do know, based upon the definition, that two base angles are congruent. So angle B and angle A have to be congruent. So that's a given. So given isosceles triangle, right? ABP, I guess, would be the name for this triangle. So from that, we know that angle A is congruent to angle B. All right. We also know, based off the definition, okay, that BP has to be congruent to AP, right? Because those two sides have to be the same. So I kind of went a little over here. I went a little overboard. It's okay. Let's go ahead and see what they're saying here. We're going to use tool define so you can use side by side angle. All right, so we're still looking for side angle side congruency. Okay. So we're still looking for side angle side triangle congruency to complete the statement in the proof. Okay. Well, we have this angle. We have, right? We have that angle here. We have this angle here. We have the side here, right, corresponding to that side here. But let's see real quick. They're saying this proof, they say draw something, right? So draw what? Well, we don't really see another triangle, do we? But how many triangles do we know for a fact exist within this isosceles? Like, what if I drew an angle bisector, right? An angle bisector, so angle bisector, and I want to call it angle bisector APB. Okay. So that means this angle, right, is going to be congruent to this angle here. Because an angle bisector, again, cuts its angle perfectly in half. That's by definition. Okay. The reason I did that is because I wanted to create two triangles out of the one triangle. Okay. And plus, we're trying to use side angle side, right? We weren't really having side angle side, but drawing this angle bisector may have freed us up now. Okay. Now we have several things here. We have two new angles, right? And I want to go ahead and call this point right here point Q. Okay. And I'm going to go ahead and say, well, angle APQ is congruent to angle BPQ. And I'll go ahead and highlight those so you can see what I'm talking about. That's this angle here, that angle there. Okay. Because it's an angle bisector, right? Those two angles are congruent to each other. And let's see, because PQ, right, which is the angle bisector line that I created, is the angle bisector, or bisect is the angle bisector of what? A angle? Yeah, angle APB. Right, which was that larger angle right there. Okay, so segment PQ is congruent to itself. So what they're saying right here is this side is congruent to itself. Okay. And now it's saying, therefore, triangle APQ, which is that side of the triangle, is congruent to BBQ, which is the left side of the triangle. Okay. By side angle side triangle congruence theorem. Okay, well, let's look. Let's look here. Let's clean this up. I'm going to clean this up. So we have our two triangles, right? and they're saying they're congruent. And well, we do know that we're looking for side angle side, right? We do know for a fact, based upon the definition of an isosceles triangle, that these two sides have to be the same, right? Yes, we were given this angle here because of the definition. But problem is that doesn't give us side angle side. So when we created the angle bisector, it gave us these two angles instead, right? And then PQ itself is congruent to itself because both triangles are sharing it. So that's how we got side angle side, side angle side, triangle congruence. Okay. So therefore, let's see, what are they trying to prove? Oh, they're trying to prove the two base angles are congruent. Oh, okay. So, therefore, angle A is congruent to angle B since corresponding parts of congruent triangles. Okay, or Cpctc. Okay, so the idea is we prove that these two triangles are congruent to one another. All right, so this triangle BPQ is congruent to triangle APQ, right? And since they are congruent to one another, we know that angle A and angle B have to be congruent. All right, because of Cpctc. All right, let's see. So in summary, whenever you have a situation where you have a side corresponding and congruent to another side and an angle, corresponding to a congruent angle of another triangle, and then right afterwards a corresponding side being congruent to the other corresponding side of the other triangle, we know for a fact this is side angle side triangle congruence. Therefore, these two triangles have to be the same. And because they are the same, I know that all their other parts are also congruent. So this angle here has to be congruent to that angle here by Cpctc. All right, again, corresponding parts of congruent triangles. I know, like, for example, this side here has to be congruent to this side here for the same reason, Cpctc. All right, this angle right here has to be the same as this angle right here because same reason, Cpctc. Corresponding parts of congruent triangles. All right, so notice how I got SAS first. Therefore, I knew that these two triangles were congruent. And because I knew that these two triangles are congruent, all their other parts, all their other corresponding parts have to be congruent to one another. All right, have a beautiful day.